Well, alrighty then. Crewton Ramone's HowSoMaths.com completing the square. I looked all over the internet and YouTube and TeacherTube and various places at completing the square lessons, and I will reserve judgment. Grandma always said, if you can't say anything good, don't say anything at all. That one guy in the Star Trek uniform on YouTube, though, dude, you deserve a medal and large amounts of money. They should be paying you $1 million, because I can assure you that I couldn't do your job. Get in front of a classroom of multiple classrooms of raving, hormone-filled teenage children in 9th grade and 10th grade, etc. Thank you, no. Anyhow, hats off to all the teachers. But here are some methods for teaching completing the square when you begin with beginners, especially like 9th graders. The student, by the way, that's doing this pointed out to me that he's 11, and 10-year-olds can do this, and I can assure you the 4- and 5-year-old kid that you see occasionally, who are quite popular on my screencasts and videos on YouTube, by the time they're 7, this kind of math will be duck soup. I'm not kidding. And they'll have baby stepped their way to it. I mean, come on, that's 2 years from now. They'll be able to do this, understand this, and explain it better than a lot of people. Let's see. All right, so let's just start off with this. Let's get back to basics, right? Every lesson, start at the beginning. Even if you just did a whole bunch of, just start at the beginning. X squared equals 9. What does x equal? 3. What did we do? We square rooted both sides. You don't see it here. What we talked about now, that just means that I have this one side is x, and this one side is 3. And I could have picked this side and this side. They're squares, for Pete's sakes, right? So any side's fine. I could have picked that side and that side, right? But understanding that what we're doing is square rooting both sides. Okay, that's step 1. Now we've got that under our belts. Now let's move on to something like this. That's x squared, 2x plus 1 and 9. Look, it's just a square and a square. But this child has already played enough with it, right? Because you remember the other a couple of other screencasts where we did a whole bunch of completing the square exercises, and the reason why we did those exercises where we didn't have it set equal to anything was so that he could easily see that now I'm just going to whip this into a square. What do? Take this right here and divide by 2, and the 1 will complete the square, and I've already got a square over here, so it's super easy, right? Okay, so there he is putting it together. And now we see he labels the sides. There's a 3, there's a 3, there's a... so, you know, we can understand the square rooting concept. And there he was goofing off with some 9s. Which had nothing to do, believe me, he was just being squirrely. Anyway, so now he sees that, oh, the economy of symbol here, instead of having it written twice like that, you could just write x plus 1 squared equals 9. And then we square root both sides, and we get plus or minus 3, right? Now, after we've done all kinds of stuff, same thing with the other students, now we can bring the concept of square rooting 9 and getting a plus and minus 3, right? Before this, when we were fooling around, we just had 9. We didn't get into the concept of when we square a number, or excuse me, square root a number, we can have plus 3 or minus 3 be the square root, because negative 3 times negative 3 is 9, and positive 3, of course, times positive 3 is 9. Alright, one thing at a time, guys. Introduce one concept, baby steps, right? Degree of difficulty. Okay, so now, and there he is writing it out in his book, we talk about, let's solve that. And I wanted to show very clearly x plus 1, this is x, this is 1, and these are 3. See, I've already made some assumptions that you guys have watched some videos and you understand that those are the blocks, what the names of the pieces are. The big red one is an x square. These are x's and these are units. Anyhow, okay, so if you haven't got that down, there's plenty of blog posts and stuff on my website that will explain that to you. But I'll assume that you've done a little bit before. This isn't your first exposure. If it is your first exposure, I apologize, and I'll explain more in a moment. Anyhow, so x plus 1 is plus or minus 3. Well, there is the first one. X plus 1 is 3. I see stuff that's same there, right? And it's so obvious, but the idea is just to be able to show it that 2 plus 1 is 3. But you want to take the stuff that's same out. There they are up here, right? We took a 1 from that side and a 1 from that side. And this is important because we're going to show 0, 0 in a minute. All right, so x is obviously 2. The other answer Now what? Ah, hero 0. There's hero 0. See this right here? This is actually 0. This is 1 and negative 1. 1 and negative 1 is 0, so I didn't really, there's nothing there. Just looks like it. It's an illusion. Alright, so now I see stuff that's the same. I take the 1 away, and the 1 away again, and now I see that x is the same thing as negative 4. See it? This is huge right here. Understanding 0. Okay, so then we fooled around a little bit with understanding our signs and how this works, and this was for his benefit because he couldn't remember what a negative times a negative was. So he did remember that a negative times, or excuse me, a positive times a negative is a negative. So here is a negative, the last one here. A negative times a positive, that just says negative 3 times. There they are, negative 9. Now, a quick lesson inside the lesson. Now I have negative 3 and negative 3. Oh, how do we get them flipped over? Negative 3, the opposite, 3 times. So there's negative 3. The opposite of negative 3 is a positive 3, and then we take it 3 times. So there's that one, and then of course that one is just the same. And here I actually wrote that down in his notebook. Alright, so now x squared, 6x, and 8. Super easy one to start off with, because it's factorable, right? We're going to use it completing the square. But he looked at that and just went, oh, that's easy, I just do this. And then we also did one that I'm not showing here that you can get with a password, where it's x squared plus 6x, minus 6x plus 8. Right? Which is basically the same problem, we just changed the blocks around a little bit. But anyway, but you could see easily that if it's 6x and 8, it's going to factor. And if it was negative 6x and 8, it's still going to factor. So he did that. Easy. Right, keep it easy. And now we're going to fool around with hero 0 and figure out, okay, we started talking about the concept of hero 0, right? 5 concepts in mathematics. 0 is 4, and no fun, get back to 1 is 5. But here, hero 0 is your hero because look, I multiply 0 by anything and it becomes 0. So this is where we get negative 4 and negative 2 are the solutions to this quadratic right here. Right, because if I make this negative 4, one side 0, the whole thing's 0. Make this negative 2, the one side 0, the whole thing 0. Right? He's your hero. And if we divide 0 by anything, he's still 0. And then he talked about identities on his own. Because if you add 0 to anything, it's just the same thing. Like, yep. Okay, so now we're going to use a little concept of hero 0. And instead now of doing that regular factoring, we're going to use this simple problem so that it's easy and understandable to complete the square, to do a lesson in completing the square again, right? Because we know where we're going. And now we see hero 0 again, right? What's our first step? Get rid of this. We don't like this here, right? So we can complete the square and put the 9 in. So here, can you see that here's hero 0 lurking over here in the form of, and since we just have the same blocks, we just pulled these guys out. So there is positive 8, there is negative 8. Positive 8, negative. Do you see stuff that's the same? Well, these are same. Get them out of there. And we now have, we're happy, and I don't have the symbols written down, x squared plus 6x plus nothing is the same as negative 8. And what's going to complete the square? Any little kid can tell you what completes the square because they can see it. 9. And they can also see why we take half of this and multiply to make the 9, right? I mean, people that bust out lovely formulas about, ax squared plus bx plus c equals, and then coming up with your happy x plus a squared equal, yeah, that helps. You think it does, but actually it doesn't. They actually have less understanding when they use those formulas. These guys absolutely understand what happens and why. Why? That was my question. I got an F because I asked that question. Why? Why do we do these things? That's why. Okay, so since I added 9 over here, I got to add 9 over here. And I have 9 and 8, and he was at a momentary lapse of reason, so we actually figured it out like a little kid would figure it out, and we got 1. Okay, so now we see that x squared, 6x, and 9 equals 1. It's a square equaling a square. That's why we make it easy this way, right? We want this square, and then we want to make this square. And if this bugger over here won't turn into a square, we use a square root sign to turn it into a square. Right? Okay, so then there's the square roots, but we don't use this very often because it mucks up the symbols on the board. They can put it in their notebooks. but they have a full understanding that x plus 3 equals plus or minus 1 is what happens after we square root, right? And there it is. After we square root, boom, that whole rest of that's gone, and we're just looking at that one side. X plus 3 is the same thing as plus or minus 1. Right there is the plus 1. Flip this thing over, do the problem solving, right? So now we've got two skills sets in one using Hero 0 to solve for it. And there was Hero 0. We put it in there really quickly. That Hero 0 was sitting there as a 3 and a negative 3. There's the 3 and the negative 3. And we just pulled out the two 3's. Combine those guys, you wind up with negative 2. And then we do it again for negative 1. Hero 0 is over there again. Take out the stuff that's same. And we still wind up with negative 3, but now it's negative 3 plus 1. And there's the negative 4. So there's our... Oops. Oh no, I didn't take a picture of the answers. Anyway, so there's the answers. Right? And it's the same as we did before. Right? So the factors, obviously, you could factor it and just get x plus 2 and x plus 4. And the answers would be x equals negative 2 and negative 4. And here we showed it again, doing it with completing the square. So now we can see that what the answer is via completing the square. And we know where we're going. It's easy, right? Okay, so now x squared plus 8x minus 9. And you'll see the kid starts running. He starts going faster than I can take pictures, literally, in just a second. So now what do? I've got negative 9 there. I got negative 9 there for a reason. But you see, he's already busted. He already took 8, and when he picked out the pieces, he picked the 8 out in 4 and a 4. Because he knows 16 is going to go there, right? He's already ahead of the game. He already knows what's going to complete the square. So now it's just getting rid of this thing, right? And there he is completing the square, and there he is. Okay, see? So he's got the 9 over there now. We moved the 9 over, but he understands that it didn't walk across the equal sign and turn positive or anything. It was just taking out the stuff that was same. And there's the 9, and here is 16. So what's 9 and 16? It's 25. That's a perfect square. And there he is fooling around because if you've seen... Go to the Pythagorean theorem page at CrewtonRamone'sHouseOfMath.com and you'll see why he's doing what he's doing, because he's played around with these blocks and he knew that he could turn it into a square. Ah, there it is, right? And so now, look at that. That's the coolest thing. I didn't expect that. But anyway, fun. See, we're just fooling around with blocks. It's not this huge thing that's scary and hard the way it is in many universities and high schools around the nation. We're just having a fun time. And look, we made a nice little design out of R25, right? So there's my x plus 4 squared. There, see it? You can see it clearly. There's x plus 4 and x plus 4. That's my x squared. These are my 8x. There's my 16 completing the square. One side is x plus 4. This side is x plus 4. Why do we do that? Because squares are easier to count than rectangles even. And this is 25. One side of that is 25. One side of that is x plus 4. And, of course, the plus or minus 5 comes in, right? I put that in there because he forgot it. All right. He's 11. Cut him some slack. All right, so now we have x plus 4 equals plus or minus 5, and he's solving for both of them. And he could see easily that, of course, one of the answers is 1, and the other answer must be negative 9, right? And we could do that with the blocks, but why when he knows the answers, right? Okay, so there's him putting the notes in his notebook without the pictures, just putting the symbols in his notebook. But then later on, he's sitting there actually drawing this one, and he's using his happy ruler there to make a nice square for 5 times 5. Okay, so there's a picture of it. See? And how far ahead of other students is this kid now that he can see this and know why we're completing the square and what we're doing? Right? And there's it. And see, the kid's lazy too. Look at this. I mean, totally, boom, from here all the way to there. Look how many steps he skipped, but he knows what's going on because he's got a picture of it, right? And this is incorrect, but later on you'll see we corrected that, right? Control of error, because it's not x squared plus 4 squared, it's x plus 4 squared is 25. And then we come down to x plus 4 is plus or minus 5, and there's the answers. Like I said, he's just lazy to write it all out, so he wrote some of the symbols down, not all of them. Which is fine, because that's what mathematicians are. They're lazy. Economy of symbol is just, you know, a nice way of saying that they want to use as few symbols possible because you don't want to write everything out all the time. Quick edit. Out of time, I just realized it's 14:48. So go to CrewtonRamone'sHouseOfMath.com for more. Check out the blog, and there, of course, is going to be part 2 of this. See ya in the next video.